What's going on, YouTube? Ugh. Yay. Nope. Next. Alright. Hello, YouTube. My name's... Ugh. I can't do an intro. I can't do an intro. I give up. I'm not a YouTuber. Yeah, so what am I doing? Okay, FreeCodeCamp. That's what I'm trying to do. Currently, I am a C/C++ software engineer. Now, no, actually, I shouldn't really say that because everyone who says C/C++ is an idiot. So I do C++ typically, but I also do a bit of C. Don't know if you can hear that. There's an alarm going off on my bloody... Oh. Is it finished? We're done. We're done. Hurrah. Right, let's fucking start that shit again. Right, what are we doing? Today is about FreeCodeCamp. I am not a web developer, but I am a C++ software engineer. I have no idea about web development, so I thought, I've been watching a few videos on YouTube, and I thought, yeah, I'll give that FreeCodeCamp stuff a whirl. And I've discovered it is actually way harder than I thought it was going to be, which is, yeah, I think I took it for granted a bit. I thought it was going to be a doddle. I thought, I've got years of experience programming, how hard's web development going to be? Well, it's not that easy, is it? So I've worked my way through the responsive web design course. I got all the way through that. I did the world's worst and least presentable websites ever just to get me the certificate, but I'm not actually planning on being a web developer anytime soon. I just feel like I need to know how to do this sort of stuff and chuck it on my LinkedIn and whatnot. Made a start on the JavaScript stuff. Now I thought JavaScript would have been quite easy for me because I've got a lot of experience in C, C++, Java, C#. I've done a lot of stuff in that, and my very first unit in my degree was doing a bit of JavaScript, and at the time I thought it was quite straightforward, but actually, yeah, no, it's not. I got through to the ES6 section and I couldn't make head nor tail of it. Absolutely did not have a clue. So I finished the ES6 section and I thought, okay, maybe I'm not the only person who's read through that and not managed to learn a single thing, even though I've got to the end of it. So maybe if it'll be useful if I kind of showed that even though I've got quite a number of years of experience programming and I'm still completely bloody baffled, maybe it'll help other people if they're beginners and stuff like that. Maybe just to show them they're kind of not alone. It might also show up that all these other people are good at programming and I'm absolutely hopeless. I don't know. I managed to con a couple of people into giving me a job, so joke's on them, eh? Okay, let's get into it. Okay, so just give you a bit of an update where I'm at. I started doing this about a month ago. So I worked my way through a bit of the curriculum. Should we reopen it? Should see something. Yep, last time I clicked on that, it didn't. Hopefully these will come up saying they've been done at some point. Yeah, there we go. Right, so I've done the HTML stuff. Got all the way through and completed my web design project. I did the absolute least possible to get the certificate because at the moment I'm not actually interested in being a web developer, but I just thought I need to learn how to do this sort of stuff. So I made a start on the JavaScript stuff. I thought this would be quite easy actually, but it's actually been fucking difficult. Not necessarily because it's like that hard, but because I found, well, some of this is like, I mean, the JavaScript stuff itself wasn't too bad, but the ES6 stuff has got some really bizarre sort of I don't know, syntax structure, and especially for things like objects, the way you instantiate objects, that's just weird. From me, who's used to working in, you know, C++. And Java, C#, but objects are quite defined about how you lay them out, and this Java, in the way it's been done in ES6, is just a bit bizarre from my point of view. So I worked my way through some of this stuff, but a lot of these I found I couldn't actually do it without having to virtually Google the answer, because a couple of these had, I don't know, like which one was it? One of these two had you had to put the exact right name for the variable in or something, or it doesn't work, which is a bit weird. I know, I appreciate everything that they've done here, but a couple of these I've found to be a little bit buggy. And quite often what I end up having to do, I'll give it my best go, do what I think should be the right answer, and then if it's not the right answer, I'm literally just copying and pasting the name of the actual assignment, assessment, whatever, into Google, and when you get on what usually happens is you go on FreeCodeCamp's forum and somebody else has come across the same problem. So they usually provide a solution, which you then copy and paste in, go to the next test having not really learned anything. So, right, so the one I'm on at the moment is regular expressions. Now, I have actually got no idea how to do regular expressions. I've never done anything like that. I don't use Linux or Unix or anything like that at all. Best I can do with regular expressions, I can put an asterisk in a wildcard. Amazing. So I thought if I give this a whirl and you actually watch me do it, now from somebody who actually does programming for a living, you know, the fact that I'm still clueless, hopefully will hopefully it'll help a few people, you know, with their imposter syndrome and that. Okay, right, here we go. Regular expressions are special strings that represent a search pattern, also known as regex or yeah, I'm not going to read that. They help programmers match search and replace text. Regular expressions can appear cryptic because a few characters have special meaning. Their goal is to combine the symbols and text into a pattern that matches what you want, but only what you want. This section will cover the characters, a few shortcuts, and the common uses for writing regular expressions. Here we go. Let's give this a whirl. Okay, regular expressions are used in programming languages to match parts of strings. You create patterns to help you do that matching. If you want to find the word "the" in the string "the dog chased the cat," I notice that's in quotes, so hopefully that's not actually sort of case sensitive. Well, it should be case sensitive, what I thought. Excuse me. You can use the following regular expression /the/. Notice the quote marks are not required within the regular expression. Okay. JavaScript has multiple ways to use regexes. One way to test a regex is using the .test method. The .test method takes the regex, applies it to a string, which is placed inside the parentheses, and returns true or false if your pattern finds something or not. Right, there's our example. So we're declaring a string, test string. We're declaring our regex, searching for the substring code, and then presumably the function test returns some sort of Boolean value, true or false, if that's actually within the substring. So there we go. Right, so this is the actual test we want to do then. Apply this regex, my regex, on the string, my string, using the .test keyword. Oh, okay, well this would be a pretty trivial example then. I'll probably still get it wrong, but we'll give it a whirl. So my string .test, and then we want the regex, which is going to be my regex. Oh, what the hell happened there? Regex. Okay. Is that it? We're not doing anything with the return value. Run the tests. Okay, Mr. Computer, you're actually going to work. Hello? Ah, right, here we go. My string.test is not... Oh, I misread this. Oh, no, sorry, it's the other way around. See, this is what you got. Always read the question. So, the regex has got the test method. What the hell? It's got the test method. And my string, what's the parameter? Your test should return true. Okay. Let result equal my regex. What am I supposed to be doing here? Is it result should return true? Oh, okay. I'll see what I've done here. So not reading the question properly. Let's try that. Hurrah! There we go. That's what happens when you don't pay attention and your computer's being a bit weird as well. It's a bit worrying. Right, sorry about that. Just switched my keyboard over there. Don't know what the hell happened. Right, on to the next one. So, regular expressions, match literal strings. In the last challenge, you search for the word hello using the regular expression /hello/. that regex search for a literal match of the string hello. Here's another example for a literal match of the string Kevin. Let test string equals hello, my name is Kevin. So we've got a new regex called Kevin. Yep, so that's basically what we did before. Any other forms of Kevin will not match. For example, okay, so it's saying it's case sensitive. It's looking for the exact string. Obviously, capital K and little k being different characters. The future challenge will show you how to match those other forms as well. Complete the regex Waldo regex to find Waldo in a string Waldo is hiding with a literal match. Right, here we go. So we're looking for Waldo, so we need to change this bit. See what I get wrong this time. Oh, amazing. Next. Alright. Regular expressions match a literal string with different possibilities. Using regexes, I don't know, like /coding, you can look for a pattern coding in another string. This is powerful to search single strings, but it's limited to only one pattern. You can search for multiple patterns using the alteration or operator, so there's the little bar symbol. This operator matches patterns either before or after it. For example, if you wanted to match yes or no, the regex you want is yes bar no. You can also search for more than just two patterns. You can do this by adding more patterns with more or operators, separating them with a yes or no or maybe. Complete the regex pet regex and match the pets dog, cat, bird or fish. There we go. Right, so we need to change that bit. So we got this all lowercase in it. Dog, bar, cat, bar, bird, whoop, bar, fish. Hopefully that's it. Ah, well, this is far easier than the last block then, so far, touch wood. Up until now you've looked at rejects to do a literal matches of strings, but sometimes you might want to also match case differences. Case, or sometimes letter case, is the difference between uppercase letters and lowercase letters. Examples of uppercase are capital A, B and C. Examples of lowercase, yeah, okay. You can match both cases using what is called a flag. There are other flags, but here you'll focus on the flag that ignores case, the I flag. You can use it by appending it to the regex. An example of using this flag is ignore case /I. This regex will match the strings ignore case, ignore the other. Write a regex FCC regex to match FreeCodeCamp no matter how it's cased. I don't know. Your regex should not match any abbreviations or variations with spaces. Right, so that's going to be the same characters. FreeCodeCamp. We want the I on the end. Is that what we're saying? I think so. Oh, boom. So far, I've only been checking if a pattern exists or not within a string. You can also extract the actual matches you found with the .match method. To use the .match method, apply the method on a string and pass in the regex inside the parentheses. Here's an example. Hello, world, match hello, returns hello. Let our string equal regular expressions. Okay. Alright, I'm guessing there'll be more use to this than there is. Obviously it's useless in this instance, but there's going to be ways of matching with wildcards, presumably. Okay, so we want to call .match on the string this time and not on the regex, and that returns a new string which is the substring of the match. Guess that's what we're saying. So coding regex, if you want to extract the word coding, and then we want this to be .match, this time with the coding regex. Sound alright? Sounds alright? Oh, okay. So far, you've only been able to extract or search a pattern once. To extract, as our example we just did. To search or extract a pattern more than once, you can use the G flag. Okay, so then we're saying let repeat regex equals repeat / G. Test string.match repeat regex returns repeat, repeat, repeat. That's what's that? It's returning an array of matches as strings. Looks like the square brackets, an array of strings. I guess so. Using the regex *regex, find and extract both twinkle words from the string twinkle star. Note you can have multiple flags on your regex like GI. Okay, so just add them together like that. So we want our regex is going to be twinkle. So we've got an uppercase and a lowercase one there, so we want them to be case insensitive, and we want both of them, so we want the G. And then that's going to be match. Okay, it's going to go well. Oh, too easy. I noticed this one, compared to the ES6 section, they're easing you into it a lot more. That was kind of, you'd have on the ES6 section, you'd have some sort of description here for about one case, and then it would be like the actual bit you had to do yourself would be, you'd have to try and infer a big leap of logic from one side to the other. It's this time they're drip feeding it to you a bit more, which is probably quite good, to be honest, because it's all a brand new topic. Okay, regular expressions match anything with wildcard period. Sometimes you won't or don't need to know the exact characters in your patterns. Thinking of all words that match, say a misspelling, would take a long time. Luckily you can save time using the wildcard character, which is the full stop or period. The wildcard character dot will match any one character. The wildcard is also called dot and period. You can use the wildcard character just like any other character in the regex. For example, if you wanted to match hug, huh, hut, and hum, you can use the regex hu dot to match all 4 words. Well, this is a question: is it representing? Yeah, it's matching one character. Yeah, which it says there. So it's not like an asterisk, for example. Okay, so we got hum string equals I'll hum a song. Hum string equals bear hug. Regex is hu dot. Okay. Okay, so complete the regex, unregex, so it matches the strings run, sun, fun, pun, none, and bun. Your regex should use the wildcard character. Okay, so that's going to be dot. Is that it? I guess so. Okay. Regular expressions match single character with multiple possibilities. You learn how to match literal patterns and wildcard character. Those are extremes of regular expressions where one finds exact matches and the other matches everything. There are options that are a balance between the two extremes. You can search for a literal pattern with some flexibility with character classes. Character classes allow you to define a group of characters you wish to match by placing them inside square brackets. For example, you want to match bag, big, and bug, but not bog. You can create the regex B. Okay, so we've got AIU in the square brackets G. To do this, the bracket AIU square bracket is the character class that will only match the characters A, I, and U. There we go. That makes sense. Okay. Use a character class with vowels A, E, I, O, U in your regex, vowel regex, to find all the vowels in the string quote sample. Okay, so it's going to be, so this is going to be the vowel regex. So it's going to be A, EIOU square bracket, and we want to, guess we want to match that, so we want to return all of them. So that match one returned the array of matches, didn't it? So we want, is that what we want? We didn't want to call test on the regex, did we? We wanted to call quote sample, don't we? Got match. Is it going to be right, or do we need to do the test? Can't remember what the difference was really. Match works on the string and not on the actual, but I don't know if the return value from those are different. Be sure to match upper and lowercase vowels. Okay, right, that was a key thing. So we want I and G. So I to match the case and G to return all of them. Forgot that bit. Right, here we go, run the tests. Oh, there we go. I'm always surprised when it actually works. Even though you think you got the right answer. I'm so used to clicking that button and it comes up with some other crap. Right, here we go. Match letters of the alphabet. You saw how you can use character sets to specify a group of characters to match, but that's a lot of typing when you need to match a large range of characters, for example, every letter in the alphabet. Fortunately, there is a built-in feature that makes this short and simple. Inside character set, you can define a range of characters to match using a hyphen character. For example, to match lowercase a through e, you would use a to e. Because that only works on characters and not funny special symbols and whatnot. Right, for example, to match lowercase letters a through e, you would use a bracket e. Okay, right, so we got cat string equals cat, bat string equals bat, mat string equals mat, bg regex equals characters a through e, and then at. So it's going to return cat, bat, but not mat. Okay, match all letters in the string. Match all the letters in the string quote sample. So that should return, because that string, the quick brown fox jumps over the lazy dog's got every single character of the alphabet in it. So if we put that in there as our match, it should return all 26 letters. And it's that T's. Well, we can make it case insensitive anyway. So we can go A through Z, quote, and we want IG. This is a question, right? Can we do? So what I didn't remember in the last one was whether match and test are kind of interchangeable for what they return. So if I do test on the regex, quote sample, will that actually return the same value? Will it return an array of characters? Your regex should match 35 items. What? Okay. That was a question, just for curiosity's sake. What about this one? So there we go. So one of them works and the other one doesn't. Yeah, so I've already forgotten what the difference between match and test is. So hang on then. Before we do anything, let's just look up the difference of this. So we've got what have we got? JavaScript regex test method. Right, okay, so test returns, right, yeah, test only returns true or false. So we do need the match function on the string and not the test function. Okay, that's good to know. Forgotten that already. Okay, on to the next challenge. Here we go. Right, match numbers and letters of the alphabet. Using the hyphen to match a range of characters is not limited to letters, it also works with numbers. For example, 0 to 5 matches any number between 0 and 5, including 0 and 5. Makes sense? Also, it's possible to combine a range of letters and numbers in a single character set. Okay, so like put one after another there. Matches all letters and numbers in Jenny's string. Create a single regex that matches the range of letters between H and S and a range of numbers between 2 and 6. Remember to include the appropriate flags in the regex. Okay, right, so we want H and S. So we've got a square bracket, H-S, and we also want numbers 2-6, okay. And we want it to be case insensitive. And we want to return the match, so we want that G character. I guess that's like a group or something that's short for, I don't know. And then this time we want quote sample, so we want to use the match method. Hopefully we get something like the right answer. Ah, yeah, okay. So we're getting there then. Right, so far I've created a set of characters you want to match, but you could also create a set of characters you do not want to match. These types of character sets are called negated character sets. To create a negated character set, you place a caret character with a little hat thing after the opening bracket and before the characters you do not want to match. So I'm guessing if you did want to match ones, but you have to make sure you want the ones you don't want to match have to be at the end of the string. So you couldn't say, oh, I wanted to not match those two, but match those. Or maybe you can, I don't know. But you probably have to delimit them somehow. Okay, so it matches all characters that are not a vowel. Note the characters like full stop, exclamation mark, blah, blah, blah. Special characters and white space are matched. Negated vowel character set only excludes vowel characters. Okay, right. So create a single regex that matches all characters that are not a number or a vowel. Remember to include the appropriate flags in the regex. Okay, so our little hat character then, or the caret character. So not a vowel, so that's A, E, I, O, U, and not a number. So I guess that's 0, 3, 9. We want it case insensitive, although it is only single case, and we want a G. So we want quote sample, which is our string. I say it's a string, but I guess that's technically an incorrect term in JavaScript. It just happens to be pointing at a string or holding one. Right, is that going to work? Guess so. Nope, cannot read property length of null. Ah, I know what I've done. I've not put the square brackets in, so I guess I have to do that. Is that going to work? Nope, still not done it. So what have we got then? What have I done? Oh. Oh, hang on. Oh, the whole lot's in square brackets. So, like that. Yeah, because if I'd have typed A-E-I-O-U, it would have tried matching exactly A-E-I-O-U. Ah, there we go. Do it 20 times and it still doesn't go in sometimes. It's crazy. Alright, here we go. Match characters that occur one or more times. This is the trouble, you see. You go through it and you do this is the trouble with learning like this without actually having a project or something, is that you do it and you remember it for long enough to do that lesson and then maybe like another 3 lessons, and if you don't come back to it, it's kind of gone. So unless you keep going over the same stuff, you're going to remember maybe at best maybe 30% of it. As long as you, but then as long as you understand the concepts, you can always kind of look it up again and learn it again. So yeah, I always assume I'm never going to learn anything from this, but as long as I learn how to work it out, that's all that really matters. Okay, anyway, that's enough of that. Right, match characters that occur one or more times. Sometimes you need to match a character or group of characters that appears one or more times in a row. This means it occurs at least once and may be repeated. You can use the plus character to check if that is the case. Remember, the character or pattern has to be present consecutively. That is, the character has to repeat one after the other. For example, /a plus slash, hang on a minute, what am I doing here? Right, A plus would find one match in ABC and return A. Because of the plus, it would also find a single match in ABC and return AA. If we were checking the string AB, it would find two matches and return AA because the A characters are not in a row. There is a B between them. Finally, since there is no A in the string BCD, we wouldn't find a match. I do not get this one at all. Right, okay, so you're using the plus character to check if a character or group of characters appears more than one time in a row. So A, B, character A does return twice because it is because they're not in sequence. Okay, so yeah, okay, so so this is the difference, right? This one here is returned one string with those two A's in a row, whereas this one, they're two separate instances of A's on their own, so it's returned two strings of A on its own rather than AB. Yeah, okay. Right, okay, so we want to find matches when the letter S occurs one or more times in Mississippi. Right, a regex that uses the plus sign. So I guess what we're expecting the return is an array with two strings, each of which have the amount of S's in a row. So there'll be two strings of SS. Hopefully, that's what we're expecting, is it? I guess. Okay, let's give it a go. Right, so in our regex, we want S plus, and we want a G there because it's a group. Say it difficult spell. Okay, so hopefully that works. Yeah, okay. Next, the last challenge, use the plus sign to look for characters that occur one or more times. There's also an option that matches characters that occur 0 or more times. The character to do this is the asterisk or star. Okay, so this is a wildcard people are probably more used to. So let soccer word equals go. Let G phrase equal gut feeling. Let O phrase equal over the moon. Let go regex equal go asterisk. Blah, blah, blah. It's interesting that G. It's interesting that that one. That actually returned. Oh, I guess it's searching for. No, G phrase. That actually returns G, does it? I would have thought if that wasn't in square brackets, that would have returned only when it's got GO. I'm guessing the asterisk is tied with the O, is it? Oh, because it could be, okay, so if the asterisk is tied with the O, then it's saying O can be there 0 or more times next to a G. Is that what we're saying? I guess so. Create a regex, Chewy regex, that uses the asterisk character to match all the upper and lower A characters in Chewy quote. Your regex does not need flags and it should not match any of the other quotes. Right, okay, so what we're saying then, we want all the A characters, upper and lowercase, but without any flags. Okay. I don't know what I was saying there then. So how are we going to match the capital A? Oh, I know why. All those A's are after that one, so it's going to be capital A, little a, asterisk, I guess. Capital A's got to be there, and then the little a can be there 0 or more times. And that kind of matches the go bit there. So the G's got to be there, and this bit afterwards could be there, or doesn't have to be. Okay, kind of got that one. This is the thing, I kind of half get it. I get it enough to answer the question, but not necessarily enough to be able to go off and do it myself. In regular expressions, a greedy match finds the longest possible part of a string that fits the regex pattern and returns it as a match. The alternative is called a lazy match. Oh, is that what the G is? Maybe greedy match? A lazy match finds the smallest possible part of a string that satisfies the regex pattern. Okay. So greedy finds the longest possible part of a string. Lazy finds the smallest. I'm not really sure what that means actually. You can apply the regex T, A through Z, asterisk I to the string Titanic. This regex is, oh, the asterisk is around, okay, so we can have as many 0 or more characters between a T and an I. Is that what we're saying? 0 or more letters between a T and an I. The regex is basically a pattern that starts with T, ends in I, and has some letters in between. Regular expressions are by default greedy, so the match would return Titani. Finds the largest substring possible. However, you can use the question mark character to change it to a lazy matching. Titanic matched against the adjusted regex of T, A to Z, asterisk, question mark I, returns TI. Yeah, okay, so that lazy match is saying return the first instance of an A and of a T and an I together, no matter how small it is. Whereas that one's saying find the biggest one. Is that what we're saying for a greedy search? So yeah, that's a lazy search. That's a greedy search, biggest one it could find. Is that what we're saying? I think so. Okay, fix the regex. Hang on, what's the square? Oh, okay, we'll try it. Right, to return the HTML tag h1 and not the text. Winter is coming. /h1. Right. So this has got to be a lazy search. So I guess we're saying I want that to be H character that may or may not be there. Question mark 1. Don't know really. So saying H and then any character or any characters that from 0 to whatever up until you match the first one. So if that didn't have the question mark there, we'd be saying the biggest bit you could find, which would be H up until the last instance of a 1. But this time we want the first one. Okay, so what we say? Oh, it worked. I work, but I don't really get it. Okay, find one or more criminals in a hunt. Time to pause and test your new regex writing skills. Yeah, this is where we're at, see, so it's good that Regis, isn't it, visiting this, because it's so easy to get it for just long enough to answer the question, and then it's gone. Okay, right, time to pause and test new regex writing skills. A group of criminals escaped from jail and ran away, but you don't know how many. However, you do know that they stay close together when they are around other people. You are responsible for finding all the criminals at once. Really? Here's an example to review how to do this. The regex Z plus matches a letter Z when it appears one or more times in a row. This is like a recap, isn't it? So it will find matches in all of the following strings. Okay. But it does not find matches in the following strings since there are no letter Z characters. Yep, fair enough. Write a greedy regex that finds one or more criminals within a group of other people. A criminal is represented by the capital letter C. So our regex finds one or more criminals within a group of other people. They stay close together, that's what it's saying. So it's going to be, there's a dot there, but I don't think we want a dot, do we? I guess we want capital C plus. Is that what we want? And we can reverse engineer it, so we want CCC. I guess that's what we want. Okay. Match begin. That was a massively overwritten question for a trivial answer. Match beginning string patterns. Prior challenges showed that regular expressions can be used to look for a number of matches. They are also used to match for patterns in specific positions in strings. In an earlier challenge, you used the caret character inside a character set to create a negated character set in the form things that will not be matched. Outside of a character set, the caret is used to search for patterns at the beginning of strings. Okay, so that's good. So there's like two separate uses for the same character. That won't make that confusing at all. Okay. Okay, so we're saying, so we've got Ricky as first and can be found in the first string. The first regex search for Ricky as the first set of characters, which it is, so it should return true. Second time, Ricky is not in the first set of characters, so it should return false. Fair enough. Right, okay, use the character in a regex to find cow only in the beginning of the string Ricky and cow. So we want... Right, we want an absolute literal match and we want it to be at the start. So that's at the start of the string and then we want it to be character for character match to that. So we want? I think so. I always get nervous. I get nervous clicking that button. I don't know what I've done wrong. Most of the time it's right, but you never really bloody know, do you? In the last challenge, you learned how to use the caret character to search for patterns at the beginning of strings. There is also a way to search for patterns at the end of strings. You can search the end of strings using the $sign character at the end of the regex. Okay, this is a never-ending story, so stuff, a lot to remember, isn't there? So we've got the caret character can be used twice inside a set of characters to negate them. Can be used at the start to match a character string at the start, and use a character to match a character string at the end. Right. Okay, so never in a story ends a story. So let story regex equal story $. So that test should return true. The other test returns false. Okay, use the anchor character $to match the string caboose. At the end of the string caboose. What? Yeah, okay. So I'm guessing we need to be saying caboose. Not gonna work. Sammy fingers, kick them in the caboose. Thing of this. Not going to remember anything. I don't know. Using character classes, you are able to search for all letters of the alphabet with A through Z. This kind of character class is common enough that there is a shortcut for it, although it includes a few extra characters as well. The closest character class in JavaScript to match the alphabet is \W. This shortcut is equal to... okay, so it's got an underscore in it. Okay, character shortcut is equal to A to Z. A to Z 0 to 9. This character class matches upper and lowercase numbers plus letters plus numbers. Note this character class also includes the underscore character. And that's \W. Right, okay, so longhand, shorthand. Let numbers equal 42, let var names equal important var. So they should all return true because they contain characters or numbers. Well, they contain at least characters or numbers, or the underscore character. They're known as shorthand character classes. Use the shorthand character class \W to count the number of alphanumeric characters in various quotes and strings. Okay, all right. I want to count the number of alphanumeric characters. I guess that's going to be W plus. Guess that's it. Oh, it's a backslash. Oh, okay, sorry. \W plus. Oh, it's like an escape character that you get in C, C++, and whatnot. Okay. Oh, that's good. Otherwise, you would never know if that was a normal W. No. Oh yeah, global flag. Right, let's try that. Shouldn't need the I because we're not being case insensitive. Should return for okay. So what are we doing? We're doing something wrong here. Let's try the I maybe. Surely that's not the answer. Right, okay, so we're doing something wrong here. Use a shorthand class \W to count the number of alphanumeric characters in various quotes and strings. Count the number of characters. I don't want like that, do I? Let's say 0 or more until the end. Oh yeah, because the plus will be no, the plus should be. The plus should say any of those until you reach the end. Ah, yeah, I guess we. Okay, I guess we don't want to. Yeah, we might have 2 sentences with a full stop between them, and that would only count the first sentence. Okay, is this going to work? Who knows? No idea. Right, okay, fine. So what are we doing wrong then? We want to count the number of characters. Your regex should find 31 alphanumeric characters. Let's just quickly do a, what was it, console.log. See what we're actually getting in result at the moment. 13. So we're only matching 13 characters from that somehow. 1, 2, 3, 4, 5. Let's do console.log. What are we actually getting? So I should be able to put this same string in here. Right, okay, so this is coming up with result is a length. What's that, like length of the array? So it's not finding them as individual. Ah, okay, so it's not finding them as individual characters. It's not finding them as individual characters, it's finding them as blocks of characters together. So that can't be right. Let's try that maybe. There we go. Okay, so finding individual characters. And each time we find an individual character, we're putting it into the array. Okay, right, let's try that then. That looks more like it. Ah, there we go. Okay. Match everything but letters and numbers. You've learned that you can use a shortcut to match alphanumerics using \W. A natural pattern you might want to search for is the opposite of alphanumerics. You could search for the opposite of \W with \W. Note the opposite pattern uses a capital letter. This shortcut is the same as not A to Z. Blah, blah, blah. Should let shorthand equal? Okay, so that should return. Numbers should return %. Let sentence equal coding. So numbers dot match. Yeah, okay. So use the shorthand character class \W to count the number of non-alphanumeric characters in various quotes and strings. Right, so we're doing the same thing. Excuse me. We want individual characters returned. We want an array, which is a set of individual strings containing one character. Okay, so that's going to be the same as we did before, but with a \W. Run. No, global flag. Yep, try that one. There we go. See, I'm forgetting that G flag all the time. I've been doing it for 20 minutes. You've learned shortcuts for common string patterns like alphanumerics. Another common pattern is looking for just digits or numbers. Digits or numbers. The shortcut to look for digit characters is \D with a lowercase d. This is equal to the character class 0 through 9, which looks for a single character of any number between 0 and 9. Use a shorthand \D to count how many digits are in movie titles. Written out numbers 6 instead of 6 do not count. Yeah, good. Right, so I'm guessing that's going to be \D. Oh, I forgot I've done it again. Match all non-numbers. Okay, so on capital D version, presumably. Use the shorthand character class for non-digits to count how many non-digits. Yeah, okay, so the same thing. Capital D. This time I'm going to put a bloody G there. Right. Oh, nailed it. Okay, right. Restrict possible usernames. Usernames are used everywhere on the internet. Ah, right, here we go. So we've got an actual real world useful example for this, because you probably would want to do this on a web page. Usernames are used everywhere on the internet. They are what give users a unique identity on their favorite sites. You need to check all usernames in a database. Here are some simple rules that users have to follow when creating their username. The only numbers in a username have to be at the end. There can be 0 or more of them at the end. Right, so us using we're going to use the $ operator or character, or whatever that is. Username letters can be lowercase and uppercase. Usernames have to be at least 2 characters long. A 2-letter username can only use alphabet letter characters. If you've only got a 2-letter username, you can't put numbers in it. Right. Okay, so we've got some constraints then. So first thing we need to check, we're saying the only numbers in the username have to be at the end. So we want, so numbers are going to be a \D Or is that like a minimum? So that's going to be a plus with a dollar. Hang on. That's got to be at the end. And then we got characters can be username characters can be uppercase or lowercase. Usernames have to be at least 2 characters long. So we need at least 2 characters to be there with an asterisk or something like that. So we need a backslash W, backslash W. So that's 2 characters guaranteed. Is that right? 2 characters, and then we want to say there can be as many characters you want after that. Slash W plus oh, do we want but hang on a minute, we no, they need to be letters only, don't they? So it can't be backslash W. So it's got to be gonna have to be well, we can make our IG. Make that case insensitive, and then we want A through Z, A through Z, and then we want another one, probably A through Z with an asterisk on it, and then we're saying that that one can be 0 or more characters, and then we want a number which can be an indefinite set of numbers that has to be at the end. I'm getting a, what have I done here? Yeah, put an asterisk in there and it'll made it the comment symbol. Even looking at that, I typed it and I still don't know what the hell it means. Oh, Jesus Christ, right. So let's type, let's do console.log. We'll copy that. We'll do username.match or something like that. Check. Ain't seeing a lot. Check that's working. Right, so we got our string username dot match. We want user check. So whatever the hell crap I've typed in there doesn't work. Let's try that, see what we get for that. Oh, see that brackets, that. What? Yeah, 1, 2. Okay, so I'm actually 3. Oh, okay. Don't want 3 characters. We want that, don't we? Okay, that's all the characters together. 3. So now we want the, yeah, so we're getting, okay. So now we want, so we've got as many characters as we can get, but now we want numbers. So we want, let's do backslash D. Plus, because the number's in sequence. Is that it? And it has to be at the end. But I don't think we need the dollar. Oh, it does work. Well, I don't think we need the dollar because we're saying all the characters at the front have to come before the numbers, so we can probably get rid of that. Let's get rid of those and then run the test. Is that going to work? So we've got all the characters at the front, and then we've got an indefinite set of numbers. Oh, except we need at least 2 characters, so we're going to have this is the key. Yeah, this is the key point. We need 1 character, 2 characters. So why doesn't that work? What have I done here? So he's not been doing anything now. Right, is it gonna work? Right, that looks that. I've broken this somehow. What have I done? A through Z, asterisk. A through Z. A through Z, asterisk. Backslash D. Backslash D plus. So we got 1 character needed, 2 characters needed, and then we got 0 or more letters afterwards, and then we got a string of continuous numbers, or contiguous numbers I should say. Is that gonna work? Oh, I don't know, I'll give up. Let's give it a whirl. No, so your rejects, oh, hang on. It should match Jack. Should match rejects guru. Is that because I made that insensitive? That should be case insensitive. Oh, maybe if I put up, maybe by having a plus there, maybe that needs to be an asterisk. And if I don't have numbers there, it should work. But if I have that as a plus, does it? It should not work. If that's not there. Yeah, that's the key. So it's got to be 0 or more. Yeah, that's right. 0 or more numbers. There we go. Let's try that then. I think we're there. We're not there. Your reject should match rejects guru. Why isn't it then? It does match rejects guru. What are you on about? Your rejects should match rejects guru. It does. Why wouldn't it match that one? It says it's case insensitive. Difference between that and that, that's all uppercase, that's lowercase. Sorry, it's upper and lowercase. That's upper and lowercase. Jack of all trades is upper and lowercase. See, this is what I was saying about sometimes I think it's right, and then actually, so go copy, paste, put that in Google. and then I'll type blah 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 blah. You Regis code is right, but the challenge won't pass. There we go. So there's obviously either something implicit you're missing, or sometimes you have to put it. You have to get it exactly what they say. Sometimes. Wow, he's got a completely different set of. What's he saying here then? So letters have to be at the front. Ah, yeah, I've forgotten that bit actually, haven't I? Letters have to be at the front. Do I have to do that? Don't know if that'll make a difference. And was I supposed to put a dollar there? Numbers have to be at the back. Nope, still doesn't match. Okay. Not sure where regex is failing the tests. Might have something to do with the G flag. I've tried a couple of different rejects that met the requirements without using the G flag, and they both passed the tests. Just let me pass the test. Gee, so what? That shouldn't do, because there's nothing stopping you having the numbers at the end or anything. The code is right, but that's not right, is it? W? Do you have an N? You're not saying that numbers have to be at the end. Right, so A to Z guarantees username starts with a letter. Okay, well, doing that is the same with what I've done. I've just been a bit more verbose about it. I put A to Z, A to Z, A to Z, asterisk. D says it can have 0 or more digits, which I did, and the dollar says that the digits are only at the end. Ignore case. So that is pretty much the same as what I've done. There have to be two. Oh, there have to be two letters at the front. Usernames have to be at least 2 characters long. A 2-letter username. Ah, hang on a minute. The only numbers has to be at the end. Ah, that's a fair point actually. So that's actually not true. It doesn't have to be 2 letters. It just has to be 2 characters. So the second character could be anything. Could be anything. So no, a 2-letter username can only use alphabet letter characters. So if it's only 2 characters long, have I read the requirements wrong right here? So the only numbers in the username have to be at the end, right? Check. Usernames can be lowercase and uppercase. Usernames have to be at least 2 characters long. A 2-letter username can only use alphabet letter characters. So we're saying that at least there has to be at least 2 characters. Yeah, okay. So I think that is right. The first 2 characters have to be letters. Do they? No. First 2 characters have to be letters. if it's only 2 characters long. But if it's not 2 characters long, they don't have to be letters. I have no idea how to get that right. I mean, I could put something that would probably get it to pass, but even this one here. So that's saying A to Z at the front. Okay. A dot saying there's got to be another character and then a number. But the thing is that that does not stop you from being able to, that doesn't stop you from saying A2. Whereas this bit, this implies you can do that, but I don't think, knowing what I know, which is not much, I don't see how I can enforce that. So we've got A to Z, A to Z, saying any character, that's not right. Any number of other characters, and then character. That's enforcing 4 characters, isn't it? Surely. Oh, I don't know. Yeah, there we go. Can you explain what that means? Let's have a look at that. The general brace expression mn that matches between m and n occurrences of the preceding term. No n match. No n means at least m occurrences. No m means match at most n occurrences, which means match at least 2 occurrences. Means match. Alright, so what you said then, this means do at least 2 occurrences as letters. I mean, I could try that, but I think we're now introducing something that wasn't actually on the curriculum yet. So let's go, what was it, 2 comma? It's not matched anything. I don't know, this might pass, but it doesn't feel right to me. No, it doesn't match it anyway. They said it does match it. So that's the same as how I had it. This is just the shorthand version of how I already had it. So why doesn't it think it matches Regis Guru? I have no idea. Let's go back to the original Google search. Right. Let's try FreeCodeCamp. Not saying that. I need a Regis Guru. Yeah, there we go. Well, this is very much more complicated than we've come across so far. So this is what I come across. I think I've got what I think. I mean, I can do a test. I've got a test there, and it returns the right value. So hit enter. We've got Regis Guru. That's what it's matching. So for whatever reason, let's do, maybe it's returning like an empty string or something daft like that. Match. I could just copy and paste that, it'll be much more useful. So if I did like a length test on that, let's see how big the array is. Length 1. No, so it is a perfect match then. What the hell? Right, we'll get rid of this crap because that was somebody else's, not what I wrote. I wrote this. And that does return the same value, so it's probably not the best way of doing it, but it is something that works with that particular value in jack of all trades. So my big question is, why fucking hell doesn't it work? What I love about this is you go get a hint and it'll be a stub. Oh no, actually yes. Okay, somebody's actually written one. Every time I searched this before. Right, here we go. There's no G in there. Oh, that guy said he had problems with the G. That sounds like a sex thing. That's not what I meant. Yeah, he was right. Okay, so there we go. Got there in the end. Right, having some dinner. Good to go. Right, match white space. The challenges so far have covered matching letters of alphabet and numbers. You can also match white space or spaces between letters. You can search for white space using \s, which is a lowercase s. The pattern not only matches white space, but also carriage return, tab, form feed, and new line characters. You can think of it as similar to the character class, \rtfnv. \r, what's that, line? I'm guessing these are like, that's like line feed, tab, well, sorry, it's going to be carriage return, tab, form, new line, what's the last one then? Don't even know what \v is. Right, okay, well, whatever. Let white space equal white space, dot space, blah, blah, blah. Let space rejects equal \sg, okay. Change the rejects count white space to look for multiple white space characters in a string. Right. So we're looking for multiple instances of \s. Guess we want \s asterisk. Does that sound reasonable? Oh, the G. Run tests. No idea. Alright, so what are we getting then? We should be getting 1, 2, 3, 4, 5 here. So if I do console.log, what do I get? I get a lot. I get what? $44? What? I bet the size of that is 44. I don't understand what's different between. Oh, hang on, maybe I just need. Do I need to do that? No, that's the one. What am I doing? Run a test. Wow, I've made that way more difficult than it needed to be. You learned about searching for white space using \s with a lowercase s. You also search for everything except white space. Search for, yeah, okay, so same as before. Uppercase is the inverse. So change the rejects, count non-white space, look for multiple non-white space characters in a string. I guess we want \s. Okay. Alright, specify upper and lower number of matches. Recall that you can use the plus sign to look for one or more characters and the asterisk to look for 0 or more characters. These are convenient, but sometimes you want to match a certain range of patterns. You can specify the lower and upper number of patterns with quantity specifiers. Right, okay, so this is what we saw in that example before. Quantity specifiers are used within curly brackets. You put 2 numbers between the curly brackets for the lower and upper number of patterns, for example, to match only the letter A appearing between 3 and 5 times in the string A. Your rejects would be A35H. Right, okay, so A4's got 4 of them, which returns true. A2 has 2, which is false. Change the rejects, O rejects, to match only 3 to 6 letter H's in the word oh no. Right, okay, so on. H 3,6, something like that. Notice there's no G on that. No. What have I done then? Ah. Case insensitive. Should not match. Oh no. Okay. Does it? Deal. Right, see what we actually get back from that. Right, I wonder if I can type an actual literal string in there and then call dot match on that. Can I do H no? Right, what did it say? Your rejects should not match. Oh no. Six works, so 7 shouldn't, but it does. Does 8? Not 1, 2, 3, 4, 5 works. 6 works. 7 does not. I don't get it. That looks like that's working to me. So, okay, does what? Okay, let's see if that actually returns true or false. So on let's just cut this string. It does match that. So something is amiss. Is that gonna work? That'll make a difference. Right, what the hell's wrong here then? So I said they must match 3 to 6. What? It's got to come after it, presumably. Why does that match? Oh, don't get that. Don't get that. Why? I'm saying 3 to 6. That's 3 to 5. That one works, and this one doesn't. So it still returns. Why? It still returns true, even though it's only matching up with. It's because it's returning true because it finds it as a subset, but we're supposed to be like, what? Oh, get a hint. Spoiler alert. Remember to use \s to include a white space followed by no. Oh, okay. That's too clever for me. So we're supposed to search for. Okay, we want a space there. Could it work? Right. Oh, so I put no in there as well, but I suppose that doesn't really matter. Guess what? No. Not that. Not gonna work. Let's try that. That's pretty much just copied and pasted in the end. That's a very specific answer they wanted there. Right. Specify only the lower number of matches. You can specify the lower and upper number of patterns with quantity specifiers using curly brackets. Sometimes you only want to specify the lower number of patterns with no upper limit. To only specify the lower number of patterns, keep the first number followed by a comma. For example, to match only the string ha with the letter A appearing at least 3 times, your regex would be HA3, comma. Yeah, okay, so just don't fit in the second number. Okay, so change the regex, ha regex, to match the word huzzah only when it has 4 or more letter Zs. So we want, because that's going to be HA Z 4, comma AH. Case insensitive. Nailed it. Nailed it. Specify exact number of matches. You can specify the lower and upper number of patterns with quantity specifiers in curly brackets. Yeah, same again. Specify a certain number of patterns. Blah, 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 blah. Specify. Alright, so we can say exact number this time. So just put that with no comma. For example, to match only the word ha with the letter A 3 times, the regex be. Right, okay. Change the regex. Match the word timber only when it has 4 letter M's. So we want TIM 4 BERI. Boom, easy. Check for all or none. Sometimes the patterns you want to search for may have parts of it that may or may not exist. However, it may be important to check for them nonetheless. You can specify the possible existence of an element with a question mark. This checks for 0 or 1 of the preceding element. You can think of this symbol as saying the previous element is optional. For example, there are slight differences in American and British English, and you can use the question mark to match both spellings. Hurrah! Let American equal color Let British equal colour, because that's the correct way of spelling it. Yeah. Let rainbow regex equal colour. Yeah, okay, right. Change the regex fav regex to match both the American English and British English version of the word.
I'm not finding anything for Jake's rejects, American English.
Apparently I turned Siri on saying something like that. Yeah, you can piss off now. Right, let's try that one again. Right, so we want favourite with a question marky over the U. Something like that. I think that's what we're saying, isn't it? Right. Is that what we're saying? Oh, too easy now. Too easy. Look-aheads are patterns that tell JavaScript to look ahead in your string to check for patterns further along. This can be useful when you want to search for multiple patterns over the same string. There are two kinds of look-aheads, positive look-ahead and negative look-ahead. A positive look-ahead will look to make sure the element in the search pattern is there but won't actually match it. A positive look-ahead is used as bracket question mark equals dot dot dot, where dot 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 is a required part that is not matched. Not matched. Alright, yeah, because I'm not actually going to do the match operation on it. On the other hand, a negative look-ahead will look to make sure the element in the search pattern is not there. A negative look-ahead is used as question mark, exclamation mark, so like a not symbol, where the dot 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 is a pattern that you do not want to be there. The rest of the pattern is returned if the negative look-ahead part is not present. So what's returned with a positive one? Just returns, presumably just returns what's not. Yeah, okay. So quit, no quit, QU, QT. Let QU regex equal Q question mark equals U. Let Q regex equal Q question mark not equals U. Quit dot match returns Q, no quit dot match returns Q. What? Because no, yeah, okay. So I'm guessing no quit dot match. Sorry. I'm guessing no quit dot match bracket QU regex returns an empty string, does it? I guess. A more practical use of look-aheads is to check two or more patterns in one string. Here is a naively simple password checker that looks for between 3 and 6 characters and at least one number. Password equals ABC123. Check pass equals question mark equals W. Okay, so saying check that there are characters, letters between 3 and 6 characters long, and there are also numbers. Sorry, there are not numbers. And what? What? At least one number. Oh no, sorry, it's not a not in there. Saying there is at least one number plus potentially more numbers. Yeah, okay, that's bloody hard work. Use look-aheads and the PW regex to match passwords that are greater than 5 characters long and have 2 consecutive digits. Right, okay, so you need to be that the propositions, aren't they? I suppose, aren't they? So that needs to be the first one. We need to say that. We need to say that it's got characters for minimal size of 5. In bracket. And we also need to say that it's got 2 digits in there somewhere. So that's going to be question mark equals backslash G with 2. So we reckon something like that. Don't know. Run the test. No. Right, okay, so what have I done wrong? Should be exactly No, hang on a minute. Does it need to be like that? Maybe? Minimum 2 digits in there? No? No idea then. Right, what have we got then? So let's try. Well. So we're saying that that is not working. So we go copy, paste. Right. Console.log. Right. Let's match that. So dot match. Our rejects in there. What the hell is that coming up with then? Nada. Right, okay. Bin this bit then. Now what? We're saying we've got at least greater than 5 characters. Well, that's true, isn't it? What have I done here? Got a minimum of 5 and no maximum. I need to do G or something like that, do I? I G. No. What's going on here then? Saying characters. I'm not logging anything. Oh, bloody hell. Let's just try something there. Let's just check we're getting something. Right, there we go. Weird. Right, so we want brackets, question mark equals, and then we want to make sure it's minimum of 5 characters. So you should be able to match at least a character. I don't understand why that's not working. No, I have no idea. I have no idea what's going on. So match. Hang on a minute. No, hang on a minute. This doesn't return. We should use 2 positive look aheads, right? We should match banner 12. You should not match ABC 1 2 3. Right, hang on. Why is banner 12 not coming up? I don't understand. Let's try B. What do we get from that? What is this? What does this return? Where dot 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 is a required part that's not matched. Positive look ahead is used as blah 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 blah. Oh, hang on. No, so I am matching that bit. I don't want to. Hang on then. So check password 36. Hang on. Let's log result. I don't really know what's going on here. Right, false. Okay. Oh, so we've got astronaut in there. Astronaut, right. Let's try this with astronaut then. Oh, absolutely bloody. Right, so we want a minimum of 5 characters. Right, so that is true. And also we have 2 consecutive digits in there. Question mark equals backslash D 2 comma. Right, so that's false, but if I made that astronaut 1 2, it is still false. Oh, for fuck's sake. Really? Why is that false? So it'll be exactly 2. Still false. It's matching it. Should be matching it, surely. So it's true. It's finding it's got minimum of 5. Right, okay. Cut that. False. Place it back in. True. Right, so we definitely got more than 5 characters. That bit's worked. Now I want to say we've got at least 2 consecutive digits. So we want question mark equals backslash D. So it's saying it's got A, right, D. That works. So why doesn't that work? It's got at least 2 digits in it together. Right, let's see what that's going. Let's get a hint. Let's see what that difference is about that. Why can't I get that to work? So what they've got in there is it's not characters followed by 2 digits. Only lower. Okay, right. Remember to use 2 look aheads. But the first look ahead, we got that one. Got that nailed. Second look ahead is similar in a given example. However, this expression must be modified to pass all test cases. Remember to specify the exact amount of numbers you want to appear at the end of the string. Oh, right, okay, so it's supposed to be exactly 2 at the end, is it? Oh, that's what they've got there, isn't it? So there's at least 1 number. So it's true, right? Still true. Oh, let's see where we get to. Right, we've got 2 positive. Yeah, I've got 2 positive look aheads. What are you on about? No, I haven't. What have I done here? Got rid of the brackets. Let's bucket that up. Right, hang on. Let's try this again. All tests. There we go. Hard work. Sure I didn't get that right. Reuse patterns using capture groups. Some patterns you search for will occur multiple times in a string. It is wasteful to manually repeat that regex. There is a better way to specify when you have multiple repeat substrings in your string. You can search for repeat substrings using capture groups. Parentheses, brackets, are used to find repeat substrings. You put the regex of the pattern that will repeat in between the parentheses. Specify where the repeat string will appear. You use a backslash and then a number. This number starts at 1 and increases with each additional capture group you use. An example would be \1 to match the first group. I do not understand that at all. An example below matches any word that occurs twice separated by a space. So repeat string rejects. Go on. Any set of characters, space, repeated. Is that right? Repeated once? So \1 is repeating. Is that what is that saying? It matches the group 1 again? If you have multiple sets of brackets, you can number them. So saying that's the same as saying \W plus, is it? I don't know what I'm looking at there. So it's separate. So it looks like that is the first. No. I don't understand that. W plus \S. Oh, let's start this again. I don't get this at all. Search for repeat substrings using capture groups. Parentheses, bracket, bracket, you use to find repeat substrings. You put the rejects of the pattern that will appear within the parentheses. Right, so in there we're saying it is a string of characters, of one or more characters. When separating it with a white space, right, and then to specify what repeat string will appear, you use a \, and then a number. The number starts at 1 and increases with each additional capture group you use. So we're saying there's another capture group. That's capture group 1, so we're saying 1's there. I don't understand where you get that. Don't understand that at all. Alright, okay, yeah, I get it. So using the match method on a string, we'll return an array with a string it matches. So that matches to this bit, and then with also along with its capture group. That's so bizarre. Right, use capture groups in rejects to match numbers that are repeated only 3 times in a string, each separated by a space. Right, so we've got a capture group. So we've got \D plus because it's numbers separated by a space. We want it matched 3 times. So repeated twice. Does that work? No. Your rejects should reuse the capture group twice. I have, haven't I? Oh, unless I was, oh, okay, maybe that's capture group 2, not, right, hang on, 1. Is that what we're asking for? Capture group 1, space 1, space 1. It should not match 42, 42, 42, 42. I don't know how to do that. How do I rule that out? I haven't specified another space, have I? What have we actually got? We've got it matches that one. Hang on, what is it? Made that 42. What do I get? Why is that returning true? was writing there. Matching rejects. Oh, it's seeing a what is it? How do I stop it matching anything else? I have no idea how to stop that. Let's have a look. Let's ask for help again. If you've already tried the read, search, ask method. Oh, hang on, I don't want that. Cancel that. Get a hint. I like the way the hints have the absolute bloody answer in them. Right, okay, so we've got capture group. Oh, hang on. No, they put their S in the capture group. Because we used our... Oh, that's the dollar. That's the key. That was the key. Make sure that's the last character. Except it does match. Oh, it doesn't bloody work. Why does that match? Oh, Joe. Hey. There's no G on that one. Oh, hang on. Right, so the numbers at the front. Hang on then. Numbers at the front. Then we're having a space. Then we're having capture group 1. Then we're having a space. Then we're having capture group 2. And they're saying that's the end. Oh, okay. I get it. So that was matching this bit, was it? So that probably works now. Yeah, there we go. It's hard work, this. Sometimes you know, it's not easy. So many of these I have to look for. They're obvious when you read the answer, sometimes. Right, searching is useful, however, you can make searching even more powerful when it also changes or replaces the text you match. You can search and replace text in a string using .replace on a string. The inputs for replace is first the regex pattern you want to search for. The second parameter is a string to replace the match or a function to do something. Okay. What? Function to do something. Right, okay, so we got the sky is silver, searching for silver and replacing it with blue. Okay, that makes sense. You can also access capture groups. Don't know what that was. You can also access capture groups in the replacement string with $signs. So camp cut. Right, okay, so you can replace. Okay, so swapped camp. Yeah, okay. Okay, so this is saying fill place here the result of a capture group 2. Write a reject so that it will search for the string good, then update the replace text variable to replace good with okie dokie. Right, okay, so we want to find good in there. So we just want good, don't we? The word good. And we'll replace that with dokie hyphen dokie. Is that it? That is it? Oh, okay. Right. Oh. Sometimes white space characters around strings are not wanted but are there. Typical processing of strings is to remove the white space. Yeah, it's quite common. Write a regex to use the appropriate string methods to remove white space at the beginning and end of strings. Note, the .trim method will work here, but you'll need to complete this challenge using regular expressions. Yes, fair enough. Right, so we want to you want some string in the middle. Okay. So we want to search for not the white space. Is that what we're saying? Hang on. Right, what are we doing then? So writing a regex, using appropriate string methods to remove white space at the end. So do we want, if we had a capture group, say \s. Is it S? So we're saying it can be up to, right, so there's the first capture group. Then we're saying there's, right, it says, oh, it could be anything in there. Hang on, so that wants to be that. And we kind of want like anything. Anything really. Oh, what's the bloody, what would be anything? I don't know. Right, so at the end bit, we want white space at the end. $. And then we want some capture group in the middle that gets everything between those two. So we want, I don't know. I'll do .asterisk. Does that work? Plus. Let's see what we come up with there then. So we go I don't know. Console.log. So you want hello.match WS regex. Ah, so stripped out the first one, but not the second one there. What is that? It's included that in the first bit. Ah, because it doesn't know. Doesn't know. One dot plus, and then let's go for say it ends in a character or something. Do I do dot asterisk \w? Nope. Yeah, I need to tell it that somewhere there's got to be a character that isn't white space. I could do dot asterisk. I could do \S. Has that worked? That might have worked. Okay, so I think we've separated that out, looks like, and then we want to replace, we want hello dot replace bollocks, how was it? It was something like, oh, was it in slashes? $2. Console.log result. Oh, maybe it works. Who knows? No, it doesn't work because there's spaces in there. Oh, just shite. It was definitely going to be replaced. So we got search value slash or regular expression. So regular expression, it's going to be that, isn't it? Oh, so close! So close. We just want the middle. We just want the middle bit, don't we? Number 2, 1, 2. Made that 1. What do we get then? No bloody different. It's not like $1, is it? I don't know. Right, fine, get a hint. I'm so close, but I don't know what it is. Actually, it was that. Hang on, no, let's kill that. We're not going to look at that one quickly. It's probably here, isn't it? Test. Do they have a replace bit in there? No. Alright, I've got the wrong one up there. Right, get a hint. Yeah, that's completely different to what I wrote. What's the bar? I can't even remember what the flipping... Oh, it was or, wasn't it? Oh, I was replacing it with an empty string. No, that's one way of doing it. Okay, so... Okay, so we're saying... that or that, replace that with an empty string. Okay. Oh, yeah. No, because that's implying there is. Salt she entered to hello world. What is result then? Undefined hello world. This is what it was, isn't it? No, it's what's the difference here? So we got S at the front, bar, backslash S at the back. Oh, there's a G. There's the bloody G in it. Right, let's go back to what I think it should be. Put the group on the end. No, it still don't work. Oh, I don't want to put a plus there. It's virtually copy and paste there now. No, I'll go and get it. So what's the difference here then? Oh, okay, okay, right. Yes, I'm not specifying what I'm not using the replace method properly. What? Right, I still think that should be an asterisk. Right, run the tests. Yeah, basically completely cheating on that one. I thought I had it, and I was nowhere near. I was nowhere near. Oh, we're done. There we go. So let's have a look at the curriculum now then. Is that finished? I think that's it, isn't it? God, it's taking so long to update. There we go. Right, web design. We've done all that one. Done all that. So I think we finished the regular expressions. Right, there we go. See, took me absolutely ages, and even now I don't even feel like I can really do it. I remember some bits of it, but as all these things, it's almost impossible to learn it if you're not actually doing it in a project. So I have to try and come up with something. I'm guessing if we have a look at the bottom, actually, maybe one of these projects will involve some sort of regular expression in it. I'm guessing one of these things does, or we're going to have to specify. Well, I suspect one of the requirements of those projects will be to use regular expressions. And as of all these things, I'll get to the point where I'm doing it and I won't remember any of it. So I look forward to that moment. Oh well, cheers. Back in the next vid.